All right, if you're getting serious about coding, you're going to hit a fork in the road pretty quick. It's the choice of what language to really dig into for data structures and algorithms. And trust me, this is way more than just learning different syntax. It's about picking a philosophy, and it's going to shape how you think about programming, period. So let's just get right to it. It's the question that pops up everywhere: C++ or Java for DSA? It's a classic dilemma, and what we're going to do in this explainer is break down what that choice really means so you can figure out which path makes the most sense for you. At its heart, this isn't really a debate about which language is better. It's about two totally different ways of thinking. With C++, you get direct, close-to-the-metal control. It wants you to know what the hardware is doing. Java, on the other hand, it's all about giving you a safety net, an abstraction that handles the messy details so you can focus on the big picture logic. And nowhere is that philosophical divide more obvious than when we talk about memory. How these languages handle your computer's memory, well, that's where control versus convenience gets very, very real. Understanding this is probably the most important part of the whole discussion. So in the C++ world, you are the boss. You're in charge of memory. You explicitly ask the computer for a chunk of memory using the new keyword. And then it's 100% on you to give it back using delete when you're done. It's a huge responsibility, but it forces you to understand exactly how your code uses resources, right down to the metal. Now, Java's approach is completely different. You still create new objects with new, but there is no delete. Instead, the Java virtual machine, the JVM, has this little background process called the garbage collector. Think of it like a janitor that's constantly sweeping up and freeing memory that you're not using anymore. It's way safer, it prevents a ton of common bugs, but you're trading that fine-grained control for convenience. Okay, so let's make this feel a little less abstract. Let's take a classic DSA problem. You need to delete an entire subtree in a binary tree. How each language tackles this simple task? Well, it tells you everything you need to know. In C++, you have to be super careful. You can't just delete the root of that subtree, because if you do, you'll lose your pointers to all its children and, poof, you've just created a massive memory leak. So you have to do what's called a post-order traversal. You go all the way down, recursively delete the left child, then the right child, and only then can you finally delete the parent node. You're managing two things at once: the algorithm and the physical memory. So how do you do that exact same thing in Java? You write one line of code. You just tell the parent node that its child is now null. That's it. The whole subtree is now unreachable, and you just walk away. The garbage collector will see it, figure out it's not needed, and clean the whole thing up for you. See the difference? Your focus is just on the logic, not the cleanup. Now, this difference in philosophy, it goes way beyond just memory. It also affects the built-in tools you get to work with, and, super importantly for DSA, how fast your code actually runs. So let's talk about libraries and performance. Both languages give you these amazing libraries, and they totally reflect their core ideas. The C++ standard template library, the STL, is all about generic programming. You write flexible code that can work with almost any data type. The Java Collections Framework, the JCF, is classic object-oriented design. It's built on a very clear, strict set of rules and interfaces. And that design choice has some huge real-world consequences. Let's just take a basic dynamic array. In C++, a vector stores its data right next to each other in one continuous block of memory. This is what we call cache-friendly, and it means the CPU can access that data lightning fast. But a Java array list? It stores references, basically pointers, to objects that could be scattered all over your computer's memory. That little bit of indirection adds overhead and can slow things down. This performance difference really starts at the very beginning with how the code gets run. C++ is compiled ahead of time. It gets turned directly into the raw machine code that your processor understands. Java is different. It's first compiled into this thing called bytecode, which is platform independent. Then, when you run the program, the JVM translates that bytecode into machine code just in time. So, what does this all mean for you when you're grinding out DSA problems? Well, for the kind of short, intense challenges you see in competitive programming, C++ just has a clear advantage. There's no virtual machine getting in the way, no random pauses from the garbage collector kicking in. You get pure, predictable speed. And when every millisecond counts, that is a huge deal. Okay, let's zoom out from the code for a minute, because this choice isn't just about passing a class or winning a competition. It's actually one of the first big steps you take in shaping your entire professional career. If you decide to really master C++, you're unlocking the doors to industries where raw performance is everything. We're talking about building AAA games in engines like Unreal, high-frequency trading where microseconds literally equal millions of dollars, robotics, and the software that runs our world, like operating systems and compilers. On the other hand, Java is the absolute king of large-scale, scalable systems. It's the engine behind massive enterprise applications. It's one of the main languages for all Android development. And it's at the very heart of the big data world with tools like Hadoop and Spark. These are fields that need robust, maintainable code that can grow to an enormous scale. So we've looked at the philosophies, the performance, the career paths, which brings us to the big verdict. And the real question here isn't which one's better. The real question is, which one is better for you right now? And to figure that out, you just need to ask yourself one simple thing. What is my main goal for learning data structures and algorithms in the first place? Okay, here's how we see it. If you're an absolute beginner just trying to wrap your head around what a linked list even is, we'd recommend Java. It lets you focus purely on the logic without getting tripped up by nasty memory bugs. But if your goal is to dominate in competitive programming, you really need that performance edge from C++. And finally, if you know you want to be a systems engineer, someone who lives and breathes the interaction between software and hardware, then the challenging but deeply rewarding path of C++ is the one for you. So, there it is. The direct, powerful control of C++ versus the safe, managed world of Java. The path of the high-speed systems engineer versus the scalable application developer. You've seen the philosophies. You know the paths. The only question left is, which one are you going to master?